We only have 24 attending the kuan, no? Pila raman mo dire. So daghang kuan. Ulang. Good afternoon, class. Can you hear me? Good afternoon, class.
Good afternoon, sir.
Afternoon, sir.
Good afternoon. Can I
Good
ask you to
afternoon.
turn on your cameras? Please turn on your cameras so that we can document our this afternoon's meeting na ni siya, di na ni kuan. Okay, do not turn off your camera, no? Ano na siya? We will talk about our exam because earlier about 10 o'clock, somebody approached me and asked, begging for an postponement of the exam because of their own reasons with other subjects. May I know who were those one? Nadere? May I know who came to me?
Kami to, sir.
Huh?
Kami to, sir.
Costa and who else?
Kami, sir.
Kinsa?
Lima na
General.
kami naman sir, dahil lima na nagkakabuo ng salat.
Okay. Now we have a problem because you were only thinking of yourself. The situation of majority of the class does not want to postpone the exam because they have already committed to the schedule. So actually, as long as there is no conflict in the exam, it should push through. Whether you have an exam in the next subject or probably tomorrow or yesterday, it doesn't matter because we have already agreed long time ago about that exam. I think I have already mentioned it to you, but you keep on begging, and I was I was considerate enough to grant you the postponement. But think about the consequence, no, of your request, because some of your classmates actually came here from far distance just for the exam. Okay, now we cannot continue with the exam today because we have already given up the room because of your request. You have already given up the room to another teacher. So, next time, when we agree on a schedule, it should happen, no? Dili kay mangayo pa ta og postponement or whatever. This is a training for you, no? Ug mukuha mo board exam, dili man mo moingos PRC nga, di pa ko ready og marasa. You are trained to be in the future, no? So, I think you have more than 1 week preparation for this. And of course, the other subjects, you also prepare for them. So I think 1 week preparation for this exam should be sufficient enough. So as of now, we have to again agree. We have again to agree on this time, when we agree, it should, whatever reasons, din na nato dawaton. Okay, katong inyong, those who came with me, who begged for a postponement, unsa tong inyong suggestion? Unsa tong inyong suggestion nga kuan? Unsa tong inyong suggestion? Katong those who ask me to, unsa man to inyong suggestion nga date for the exam?
Depende ninyo, sir.
Abi na ako ni-set mo og date.
Ang uban ko no, sir, kay dili ko sila available on Friday.
This
So,
Friday also, dili pa
Monday,
kayo klaro. This Friday dili pa klaro kay naamon tay Teachers Day pero ambot lang og madayon ba? Kay nakuan man na irog man ang Teachers Day sa kuan. I don't know, wala po. Pero I'm not sure also madayon. But anyway, we will not have it on Friday kay. So unsa man? Those who are others who are listening online, unsa man inyong kuan suggestion? Atong ni request na ko unsa to inyong kuan? Unsa to inyong request atong kuan?
na imong sa anong, sir, kanang Monday.
Unsa to?
Monday.
Monday to
Pero-
inyo. Pero
Pero
unsa
ang
man?
kung pwede ba sa uban po?
So Monday ang inyong gi-suggest.
Yes, sir.
Atong isa nimo kinsa to si Acosta ba tong isa?
Yes, sir.
Mo to inyong, do you agree nga Monday ang inyong kuan? Suggest?
Kanang sa amo ang gi-suggest, sir, baka nagingon namo, sir. Mao pa na mo gikisabutan ra sa group chat namo, sir.
Sa group
Ingon
chat
pa lang
ninyo
na-
pero wala mapil ang uban kay Napa may
Kanang
nitawag
kanang kwan
nitaw
sir ni hangyo ni message si Anjin sa kwan sa Pikas section ni ask siya if pwede ba daw mo hangyo ni sir niya ni like naman sila sir so gitik na mo to nga okay ra.
Okay. For those who are here, Monday ang ilang kuan. Ha? Next week, ang Monday is free sa kuan, sa conference room. Wala. Ang Wednesday na. How about the others? Can you Monday is the initial suggestion. Okay ra mo dire? Okay, those who are here in person in the classroom, okay ra kuno sila og Monday. Okay. How about you? I'm going to ask you one by one. Si Timunan. Unsa man ka Timunan? O naaman dire? Ha? Acosta. Hello. Acosta, okay ra?
Okay ra sir? Ako sir?
Bugkasan.
Sir, okay na sir.
Gadayan.
Sir, okay na sir.
Habel.
Okay ra pod, sir.
Soria. Wala si Soria? Valencia.
Okay ra sir?
Richmond. Lagahit.
Sir, okay na sir.
Masiyas.
Sir, okay na sir.
Putelan.
Okay na sir.
Magtahas.
Okay na, sir.
Cuesta.
Okay na sir.
Bernales. Paalan.
Okay ra, sir.
Cuba. Moreno.
Yes, sir.
Tangkalagan.
Yes sir.
Anoos.
Okay na sir.
Generoso.
Okay ra, sir.
Amorganda. Isa to?
Okay ra. Okay ra, sir.
Okay na sir.
Mungkopa.
Okay na, sir.
Salatan.
Okay na sir.
Moreno.
Okay na ako ganina, sir.
Oh, Bulingot.
Okay na kayo sir.
Padayhag.
Okay lang, sir.
Makay.
Okay na sir.
Postigo.
Okay na, sir.
Meral.
Okay ra, sir.
Galoy.
Okay na sir. Okay na sir.
Bartolay.
Okay na, sir.
Okay, so far, those who responded were positive to the new schedule of the exam, which is Monday, October 17, from 1 to 3 p.m. in the afternoon. Okay, we will have it on the third floor of the conference room of our CAA building. Okay? So, for those who are here in person, na ay I'm asking dili mo okay. Wala ra, okay. So because if I'm going to ask kinsay mo okay, alingasa kayo. Okay, so we don't have anything to do. I'm going to explain what is on the board for now. Unsa? Naidili okay? Naidili okay? Okay, Ras. So those who are connected online, you just follow us on the board. Okay, class, can you see what's on the board? Class?
Yes, sir.
Okay na? Makita ra?
Yes, sir.
Okay. For this afternoon, we will be discussing one of the common components associated with shafts, which is the coupling. Specifically, flange coupling. You can see it in your PDF file. I tried to draw it the best I can. Okay, so your flange coupling joins two shafts together. If you have a shaft that you want to join them together, you use a flange coupling. Okay. There are other couplings that you can use, but this is the most common, or the flange coupling. This flange coupling, there are two, no mirror. This one is attached to the shaft on the left, while this flange coupling is attached to the shaft on the right. Now, if you join the shaft together, then you bolt the two, then of course you are going to carry whatever rotation on the left side to the right side, or from the right side to the left side. Okay? And you attach these two flanges, it is shown here, by bolts. So kinesia, these are holes for the bolts. And for the example, there are 6 bolts. 6, and the size of the bolt is 5/8. Okay, so to understand this, by the way, you know what is this? Huh? It's a key, because the flange without any key will not rotate with the shaft. Mudandog na siya. So you have to insert a key. And there's also another key here. Now this is called the hub. This part here is the hub. And this one is the flange, no? But the whole setup is a flange coupling. But specifically, this part here is the flange, and this part here is the hub. So if I'm going to draw it, ana na siya gitsura. Then, of course, this is your shaft, and there is a key. No? The key, of course, gets in through, no? Gets through. The other side, no? Now the dimensions are given. The shaft diameter is this one, no? Specified 2 and 3/16. The hub diameter is 4 and 1/4. And the bolt circle, this is the bolt circle, no? The diameter of this is the bolt circle. The diameter of the bolt circle is 6 inches. Okay, 4. The coupling shown, the key is 1/2 by 1/2. You look at your table for keys, square keys. What is the recommended size of the square key for a shaft of 2 and 3/16? Insa itong nakadala sa kato akong gihatag. What is the range? What is the range for 1 and 13, 16 to 2 and 1/4? That is the range of the shaft. And your key here should be 1/2. Okay. This is found in the PDF files that I have also given you. So that is why this is okay. The shaft is 2 and 3/16. So the key is 1/2 by 1/2. And the shaft carries a steady torque of 50 horsepower at 150 RPM. All parts, meaning the shaft, the key, and the flange, has yield point in tension of 60,000 psi, and the yield point is in shearing, as you already have known, is 1/2 of the yield point in tension, so 30,000. We are going to find the stresses and the factor of safety based on the yield point. Okay, so there are 4. First is we are going to find the factor stress and the factor of safety in the key. Now there are 2, the shear and the bearing stresses in the key and their factor of safety. Then the next one is, of course, in the bolts, and then this one is the shearing on the bolt. And then this is bearing on bolts in flange. And the last one is shearing of the flange at hub. Okay. The least complicated here to analyze is the first one because it is the key. So for the key, remember force over area is stress. We need the force. So what should be the force that we are going to use? Of course, the force on the key, which is, where is it located? Of course, here. No? But before we can compute for that force, you will notice it is not specified what is the force. However, it gives us an idea that we are going to use the power and the RPM to get the power and RPM. Formula sa power and RPM. Unsay anon dito aron kuha na to. Torque 2 pi Tn. Power. We know 2 pi and N. Or T omega. No? where T is the torque and omega is in radians per second ba or minutes ba or whatever. So from this, we can get the torque. And remember, torque is also, how is torque defined? When you say torque, it is a twisting action on the shaft. Okay, if this is your shaft, then that is your torque. How do you define this? Torque is force times what distance? Radius. Okay, this is your radius, and this is your force. This is your force, and this is your radius. Then the torque for that is force times radius. So based from this, if we know the torque based from horsepower and RPM, we can get the force, we can get the torque, and based from the torque, we can get the force given the radius. So, we'll first compute for the torque. Power is 2 pi Tn over 33,000. Why is it 33,000? This is 2. What is the unit on top? Kanang 2 pi Tn. Given the units here, RPM and 150. Ilay mo gawas aning 2 pi Tn? 2 pi has no dimension. Torque should be in, and N should be in what? Revolutions per minute. Okay, so what should be the torque, unit of the torque here? Okay, if it is 33,000, it is in English units. So it should be
Inch pound, sir.
foot-pounds. Okay, so you have 2 pi Tn. This becomes foot-pounds per minute. And the equivalent of that in horsepower is 33,000. So you substitute 50 horsepower, you get the torque. Are we all right here? You understand? Okay, so once we know the torque, this is the torque that is twisting the whole assembly. Meaning, if your radius is small, for the same torque, your force should be bigger compared to when the radius is larger, your force should be smaller because the same torque. Asa naman to? Torque is force times radius. If the torque that is being supplied by that power is this one, then if you have a radius of smaller radius, you should expect a higher force. So that when the same torque, if the bigger is the radius, you have a smaller force. Okay. So I converted this into foot-pounds, converted it into inch-pounds because our units here are all in inches. Okay, inch-pound. So let's look at the shaft. Why is it that we are going to determine the force on the shaft, on the surface of the shaft? In other words, the force here, and of course, sorry, kini mo na shaft. The force there, given the torque. Why do we need this force? Because what is our next step? What is our next step? why not determine the force here or determine the force here? Why determine the force here? Where are we going to use this force?
Para
It is
ma-determine
used
yung
on the
computation.
computation of the stresses of the key. If we compute the force here, then that is not the force that is acting on the key. So, for the force on the shaft surface, that is where you mount your key. Okay, torque. Now you will notice it's now in inch pound, and this is in inches. Radius, no? 2 and 3/16/2, that's radius. So you will have 19,207.73 pounds of force acting on the key. And it is also the same force acting on the surface of the shaft. If you try to recall our discussion of keys, this part here, the surface of the shaft is pushing this side. The rotation is in that direction, assuming that the shaft is the drive, no? Ang tuyok ani is this shaft, because it could also be in the other side nga ang shaft sa pikas nga side. So the power is coming from the other side and it passes through the key and here. Okay? So when the surface of the shaft and the surface of the key pushes against each other, the stress on the surfaces are called bearing stresses, which is similarly defined in formula as compressive stress. The difference between bearing stress and compressive stress is that the stresses occur on the surface when it is bearing. But when you have a compressive, it is internal, so within the body. You are compressive here, you evaluate inside. However, when the surfaces are in contact and your evaluation of the stresses are on the surfaces, that's called bearing stress. And it is being used commonly in the field of civil engineering. No? When the foundations of the building press on the ground, that is bearing stress. So it is the surface of the foundation and the surface of the ground. Okay. So let's go back. Now, shearing of the key. We now have the force acting on the key. What is the shearing area? What is now the shearing area? So your force is acting here, and your key will be sheared where? If this is your key, asa man na siya maputol? Because shearing man na siya, it will be sliced. Here. Diyan na siya makuan. So what is the area? 1/2 1/2 by the length of the key. What is the length of the key? According to the drawing, it is 3.5. But you will notice that this part here, there's a part here that is unoccupied by the shaft here. Meaning the shaft here is only up to this portion. Dili gyud mo tupong ang shaft sa imong surface aning imong flange. Nisulod siya gamay. Now, what is the reason for that? Para na ay the reason for this one is not for expand for what? Usually, for this, thermal expansion is not considered. So that's not a valid reason. Now the valid reason here is that your shaft on the other side can get through this part. And why does it have to get through? What is the reason? Kining nga part ba? Kining nga protrude pod, musulod na siya dito. What is the reason? You will notice na iga-protrude. Now, this flange will carry that. Dili ang shaft. Key raman ang kuan. Okay, remember, from the shaft to the key, from the key to the hub, and goes to the flange, transfer to the bolts, to the other side, on the flange, and then it's transferred to the hub, and to the key, and to the shaft. Muna siya ikuan, ha? Okay, so what is the reason why ang isa ka flange, ang iyang shaft tuwa sa sulod. Unya ang pikas diri nga pares niya gagawas, ga-protrude, no? Ga-protrude siya. Ipagkuan nimo. What is muslide? Dili man gyud siya muslide kay it is being held by the bolts. The bolts are actually holding. There are 6 bolts. Siya ro muslide pa na siya. Unsa to? Okay. So that your shafts will be correctly aligned. Kay og imo na siyang ipatupong ra, there is a tendency nga pag assemble mo ana tingali siya or mo ana. But if imo ipasulod na dito unsang pa man niya pagkuan. That is for the reason why naana sa inyong PDF file ha kanawa. I tried my best
Nawala, sir.
Murag
Wala dyan.
Class, are you still there? Can you hear me?
Yes, sir.
Sorry,
sir.
I forgot to plug the cord. Asa mo taman dapita? Nawala inyong kuan. Ha? Asa mo dapita taman nawala?
Katong ano sir, katong nganong nasa sulod tong usa ka key.
Ah, okay. So dapit sa itong. So are you following me now?
Yes sir.
Okay. Did I say the reason for why do we have to insert this? Ah? This part of the shaft is protruding while the other shaft is recessed, no? Di paatras. So when you assemble the flange coupling, you are going to have a perfect alignment of the shafts. That is the reason. Okay. So we are going to compute for the shear and bearing in the key, shear in the bolts, bearing in the bolts, and shear of flange at hub. To get those stresses, we need force. So we need force. And we can only get force from the drive. Our drive here is 50 horsepower at 150 RPM. So from that, power is 2 pi Tn. We know the power and we know the N. Then we can get the torque. And then we substitute values. 33,000 is conversion. Because what will come out here in the units on top will be foot-pounds per minute. You convert it into horsepower because your unit of power here is in horsepower. You divide by 33,000. And then you substitute all the values. Your unknown will be T. And computing for the T is this one, 1,750.704 foot-pounds or 21.0845 inch-pound. That is the torque that is twisting or driving from one side of the shaft to the other side of the shaft, where the power is passing through from the shaft to the key, pass on to the hub, pass on to the flange, then from the flange, pass on to the bolt, and the flange on the other side to the hub, and the hub to the key, and ultimately to the shaft. Do you follow, class? Class? Are you still there?
Yes, sir.
Okay. So, if we compute for the shear and bearing in the key, we need a force in the key. Now remember, torque is equal to force times radius. Now this torque is being transferred from one side to the other, and it is the same torque. However, from the definition of torque, which is equal to force times radius, for the same amount of torque, if your radius is bigger, then your radius should be smaller. To have the same amount of torque, if you have a bigger force and smaller torque, a smaller radius, no? So kinahanglan for the same amount of torque, product of force and radius to be the same. So madako gani ang force, gamay ang radius. So that it will be the same when magamay ang force, then your radius should be bigger. So, however, we already have the torque. Now, for the key, the force that is acting on the key is on the surface of the shaft. So therefore, to get the force on the shaft, on the surface of the shaft, we need the radius of the surface of the shaft, which is 2 and 3/16 over 2. This is diameter, 2 and 3/16 divided by 2. And our torque is, this one is converted. No, I converted it to inch-pound because all our units here are in inches. So our force here is 19,207.73 pounds. Dili siya square hard, apil na siya diri. Are you following, class? Class, are you following? Okay ra? So let's proceed to computation of the stresses. First is the shear and bearing in the key. So the force on the key is actually the force on the surface of the shaft. If you look at this, the force acting on the key is the force that is on the surface of the shaft. So the shearing stress is the force that is acting on the key, which is the force on the surface of the shaft, divided by the stress shear area. Now again, the shear area is the shear area of the key is this one. Now it will be sheared in the middle, and therefore the shearing stress will be this one, or the shearing area is this one times the length, and this is 1/2. 1/2, and the length is 3 1/4 because we follow the key, which is the shorter key. Now this side of the key is shorter. It's supposed to be 3 1/2, but it is shorter by 1/4. Okay? So the shearing of the key is force on the surface of the key, or force acting on the key, over the shear area, which is 1/2 by 3 1/2 minus 1/2, or 3 1/4. And it is 11,820.14 psi. Now, for the factor of safety, we are going to use the yield point in shear of the key, because what we're talking here is the shearing of the key. Yield point in shear of the key over the force acting on the shearing area, and it is 2.538041. Okay, class, any following? Class, are you still following?
Yes, sir.
Okay. Now for the bearing. Bearing stress is the stress caused on the surfaces of the shaft and the key in contact. Or this, if the shaft is rotating in that direction, this surface of the shaft is pushing the surface of the key. And that surface will have a bearing stress. There's a bearing stress on the surface of the shaft. There is also a bearing stress on the surface of the key. So, the force here is already given. However, the area is this one times the length of the key. And what is this? It is 1/2 of 1/2 of 1/2, because your dimension of the key is 1/2, and it is only this part here. So it is 1/4. So your bearing on the key is 1/2 of 1/2, or 1/4, times the length of the key that is shorter, 3 1/4. So we will have here a bearing stress of 23,640.28 psi. The factor of safety is yield point in tension over the actual shearing stress, bearing, no, sorry. Okay, manggihapon na siya dahil okay na siya. Bearing stress on the key, which is 23,640.27. So our factor of safety is still 2.538041. Now the forces on the bolts, as I have mentioned, it is the stresses on the bolts should be the force on the bolt over the area that is being sheared. So if this is your bolt, and this two here is your flange. As your flange from one side rotates, the bolt transfers the motion to the other side. However, the action of shearing will be this way. So what should be the shearing area? Ana man. Ana, no? Ana pagkakuan. Ana pagkakuan. So what should be the shearing area? The shape of the shearing area should be circular. Circular ang shearing area. So, first we need the force on the bolts. So the force on the bolts, if we go back, for the same torque, this time the force on the bolt is not the same. Because, as the key, because it has a different radius. So the same torque, but different forces now because of difference in radius. So, going back, the force on each bolt, because there are 6 bolts, no? Is of course the force, the torque over the radius. How much is the radius? The diameter of the bolt circle, is 6. So it should be 3. Or 6 divided by 2. This is your radius. However, this is for all the 6 bolts. So for each bolt, you divide it by 6. Force on each bolt. Because we are not analyzing each bolt. So, asa? Dere? Dere? O isa ra kawan? Isa ra sa kawan? Dayon, okay na nangoban. Sorry, no? Sorry. So, we will have the force on the bolt is 1,167. So the shear on the bolt is the force on its bolt divided by the shearing area, which is a circular area. So pi d squared, that is pi over 4d squared, over the force on the bolt. I think this is correct, no? Exacto? So I just, okay. Of course, the factor of safety will still be yield point in shear over the actual shearing stress. Is this one. So our factor of safety here will be 7.885871. Those online. Now for the bearing on bolts in flange, this time the bolts is being crushed because of the force on the flange, no? This is your bolt and this is your flange. Your bolt will be crushed because it is being pushed in from one side. There is a force from the flange on this side. So this area here is being compressed. But the force is in that direction. And remember, bearing and compressive stress is normal stress, wherein the area and the force are perpendicular. So it should be a perpendicular area of the bolt. So it is not this area, but it is the projected area. Because your force here and your area should be perpendicular. We call it projected area. So this is the diameter of the bolt, and this is your force on the bolt. From the flange, sorry. From the flange to the bolt, which is the forces on the bolts. So our area here is the diameter times what? Remember, this is your force here acting on that area. So it should be the diameter times this one. Okay? From here, it should be the diameter of the bolt times this one. The diameter of the bolt times this one. Okay. So the bearing area is 5/8 by 5/8. It is a rectangular area. So our bearing stress will be the force on its bolts in flange, no? So the force on its bolt, because we're analyzing per bolt, which is, saan na to? Force on its bolt, this one, 1,000. Sayop yapon eh. Is this correct? Kira. So 1,167.136 over a rectangular area of 5/8 by 5/8. So the factor of safety is, again, yield point in compression or tension over the bearing stress on the bolt, which is 20.081207. Now, for the hub, you will notice that the hub is something like this. That is the hub. And of course, your shaft is inside. And then your flange is here. Align mo flange, no? It's being attached here. Now, when the hub is being sheared, there are two ways of shearing the hub. Let us say this is your wala may laing lingin dali nga kuan. Let us say this is your hub, and this is your, yes, this is your hub, and then your flange is here. No, gaana man yung flange dire. This is your hub. One way of sharing it is this way, meaning maputol na siya diha. Another way is, paingon dito ang putol. Meaning,
Dili mo kita, sir.
ay sorry. Let us say this is your 1, 2, 3, 4, 5, 6. Okay. This is your hub. One way of sharing it is maputol na siya and this will separate. So naa diha ang kuan. Meaning the hub is the board. Oh, sorry, the flange is the board. This is the hub. Pwede siya maputol, ana. But another way is, mulapos na siya dito. Mulapos na siya, ang katong dito sa kuan. In other words, if this is your, ana ba, if this is your, kini akong kamot is your flange, and this is your hub, maana pagkaputol. Dili, dire. It is still shearing, but this is also still shearing, twisting. This one is, you are going to shear this part here. Separate it. You're going to separate this part here from the hub. Now, this part here is stronger compared to this part. So in consideration, our shearing case for this is, ana, maputol siya nga ana. Meaning, I'm going to draw it. Kani siya, nani siya sa sulod. This part here is inside the hub, or the flange. Ana nga pagkaputol. Rather than, ana nga pagkaputol. Dire lang. By the way, the sheared area is this one, ha? Sunod na siya dito. Now, another case is, this is the shearing area. Kini ang shearing area nimo. Wala. Naman ay bangag ganing kuan. In fact, wala din nani bangag ning hakuan. Naman ay bangag ang hub. Hub man ni siya. We're talking here of the hub. Ay sorry. Nay bangag ning hub. Kaya naman day ang shaft sa sulod. Ana na. So, kini siya mo na shared area. While this one, it is this one. And, kani, gatapot mo na silang duha unta. Kani siya, kaning dire nga surface, kuan, di makita. Now, it's supposed to be this one. That surface there. Now, what is being considered here is this one, because this one is weaker compared to this one. Because the stress here are higher because Remember, for twisting, PR over J, when the R is small, gamay imong stress. No? So, what is the stress area here? Or the shearing stress area? Unsay shape sa shearing stress area? Okay, it is something like this. Muna siya imong shearing area. So how do we get that shearing area? Circumference times this one. The thickness of the flange. So that is why the force on the hub first. So this time we are going to talk about the force acting on what part of the flange coupling will be sheared. And let's go back to the drawing. We are now talking of this side here, this part here, this part. It will be shared here. So we are talking of a different force because first we have calculated the force on the key. Second, we have calculated the force on the bolts. But this time it will be shared here. So another force on the surface of the hub. Do you follow? So what is the force on the hub? Based from the torque, force is equal to torque over radius. The radius is of course where the shearing will occur, which is on the surface of the hub. So pila man ang kuan? Radius. 1/2 of 4 1/4. It is 1/2 of 4 1/4 because what is indicated in the drawings there are diameters. So the force on its hub is the torque over the radius. It is 9,086.33 pounds. The shearing area it's like a kanang band, no, band. Murag ribbon ba nga gi kuan, gi lokot. No, there's no other. Lingin siya nga na siya thickness, unya na po siya circumference. Kini, no? Kini nga area. So it is pi d times the thickness. Okay? Or 2 pi r, no? 2 pi r or pi d times the thickness. So that is your shearing area. And of course, your shearing stress on the edge of the hub is the force on the hub over the shearing area. And we will get here 1,184.721 psi and a factor of safety of 25. No? Yield point in shear over actual shearing stress. So our factor of safety is 25.32241. Okay. So evaluating all our results. If in case there is an overload, meaning probably nasubraan ra og kuan, no? Nasubraan ra og ang imong drive, ang imong load, nasubraan ra sa imong desired. Meaning di nakadaog ang imong joint. Which part of the joint will give way? Why is it the key? Because it has the smallest factor of safety. And that is also true with our discussion before. That the case is like a fuse. That in cases there is an overload, it should be the one that will give way. Because it is easier to replace a key than to replace a hub or replace a shaft. A key is only a very small portion, no? Kung sa electrical na siya, ang fuse, paliton ra nimo. Barato ra kayo kaysa imong mga lambre mo yung mga kuan, no? Okay. So any questions? Oh, unsa man? We always take, why we choose this one? Yes, sir. Oh. If we choose this one, it is shorter. Actually, we can also analyze this. It is longer. But we expect that the factor of safety of this one will be smaller. Now, in design, we always look for the weakest link. Dili ta mo design atong lig-on kayo, kaya di mo to siya maunsa. Anita, we will investigate that part. We will investigate that part where it is weaker. Pwede ra po na, ikuha na to, ibutang, pero of course it is practical nga, dako na siya ang factor of safety. Yes. Duha ka key. Actually, that is possible. In fact, katong Kennedy, duha to siya ka key, pero lain lagi tsura. But you can make it, pwede, no? Katong Kennedy, anak man to? Anak man to Kennedy, if you look, katong kuan na? Ang inyong na, Kennedy? This is Kennedy. There are two. However, for most applications, we use a square key. Pwede, you can use a square key. Yan na dere, ug na po dere. You mean who's the one that is asking the question? You mean this one? Oh. It depends on your application. However, you have to take note that your stress concentration factor here is higher because you now have two. In fact, the spline is like a gear. Daghan siya kuan, no? Ana man ang spline. Ana man ang spline. It's like a multiple key. But this one, it is incorporated in the shaft. Nakita mo ani, those who are investigating kanang mga cars, no? Cars. Usually it is, you will find this in the transmission. The line shaft connecting the transmission to the Katong sa luyo nga kuan, drive shaft. You know what's the reason for this? Ngayon ani? Why is it that way? Pataas man ni siya, di ba? Now, this is also being attached with its pair. However, it can slide because taas man eh, it can slide. It will still be driving even if it is moving because this is long. So, what is the reason for that? Nga pwede siya, nganong dili, permanente ko siyang attach diha og dire. Because your drive shaft is, vibrate, aside from vibrating, it will bounce with the kanang rough road. So, pwede siya nga moana. Pwede po siya moana. Magana-ana ba? So, meaning, ug ma-rigid ni siya, maputol na imong kuan. Kinanglan, pag ana niya mo, atras siya. Pag ana, that is for the misalignment. When you have two that are not aligned together, that is different. But, wala na siya. That is not the reason for this nga nung kuan kay pag ana niya mo ani man ni dire. So that is why it has to slide. Kani sa spline. Pero lain na to siya, it's a universal joint. Kanang even if your shaft are not aligned, they can still transfer the rotation. Unsa? By the way, we discussed square K, no? Square K. So square K ra atong kuan. If you have two, it's the same. Parehas na magyapon ang mga forces, ang mga kuan. Doble ra. Okay, you take your screenshot for those who are online. Any other questions? Dili. One piece na siya. One piece ug malubag siya then magbulag. So, what is really the analysis here is your joint here strong enough to resist the shearing? Kani mo man imong flange, kani imong hub. Is this joint here between the flange and the hub strong enough to carry the torque? Katong kuan, shearing on the hub. Okay now, have you taken your screenshot? Okay, you take your screenshot for the second board. Can I ask you to, inom ta, inom. Can I ask you to turn on your cameras, please? Turn on your cameras. Okay, so class, I think we're done. So it is final, no? Our exam will be in the conference room, Monday, October 17, from 1 in the afternoon until 3. Okay, class, we're done.
Thank you, sir.
Okay, you're welcome.
Thank you, sir.
You're welcome. Okay, you can go now. Those who want to take pictures, make sure nga dili makuha ng camera.